Okay, this is the Chapter 3 test, the FRQ portion explained because we didn't have time in class to go over it. Okay, so number 11, researchers studying a pack of gray wolves in North America collected data on the length X in meters from nose to tip of tail and the weight Y in kilograms of the wolves. A scatter plot of weight versus length revealed a relationship between the two variables described as positive, linear, and strong. For the situation described above, explain what is meant by each of the following words. So positive, they wanted you to say something about as the wolf length went up, then the weight of the wolf also went up, or as length increases, the weight increases. So I said the higher the wolf length, the higher the wolf weight. Okay, notice I'm not saying just X and Y. We have to describe it in the context of the problem. So we've got to have the wolf length and the wolf weight in there as well. Okay, for linear, we want to say the points generally follow a straight line, or the points generally follow a straight pattern. Okay, it's important to use the word straight. Another thing that I did accept as a correct answer was to talk about that you had a constant rate of change. Because you guys know that something is linear, but we have a constant rate of change. Some people also described it, to say it's not curved. That was okay, but we're really looking for that keyword straight. So when for linear, you want to use the keyword straight. Okay, for strong, we want to say the correlation is close to 1. Remember, correlation is our R value, and that tells us our strength. The closer it is to 0, the weaker it is. And since they said we do have a strong relationship, then we know our R value is close to 1. And we know it's close to 1, positive 1, because it's a positive slope. If it, if part 1 was having us define what negative means, then we would be saying our correlation is close to -1 in order to be strong. So grading these, all of these were 4 points apiece. Each one individually, okay? And then part B, it says the data collected from the wolves were used to create the least square regression equation y hat equals -16.46 plus 35.02x. Interpret the meaning of the slope of the least square regression line in context. So you had to give the value of it and you had to interpret it correctly. So this problem was worth 4 points, but I did separate it for you. Interpreting, I gave you plus or minus 2 points. If you interpreted it correctly, and then actually giving the value was worth the other 2 points. So that's where you got your total of 4 points. So if a person just in part B wrote 35.02 and then some crazy explanation, then they may have gotten just a -2 for not interpreting it correctly. What you want to do with your slope is you always want to take it, and it is always the number that's in front of X. You want to put it over 1, and you want to associate your top number with Y and your bottom number with X. In the context of this problem, Y is our weight, okay, and X is the length. And by the way, our weight is in kilograms and our length is in meters, okay, from the original scenario. So you would want to write a sentence saying for each, increase in length in meters, we would predict an increase in weight of 35.02 kilograms. Please get in the habit of using predict. I did not take off any points at all for not using the word predict, but I promise you on the real AP exam on a question like this, if you don't use the word predict or estimate, that it's estimated to be that, they're going to take off points. You will not be able to get full credit, even if everything else about the problem is correct. So be careful for linear regression. You always want to use the word predict. So for each 1 meter increase in length, we predict the weight will increase, because it's positive, by 35.02 kilograms. Okay. Interpret the meaning of the y-intercept of the least square regression line in context. So again, interpret was 2 points, and then actually giving the correct value of the y-intercept was the separate 2 points, for a total of 4 points for that problem. So if you at least said the y-intercept was negative 16.46, then you got half of it right, but you needed to write a correct interpretation as well. And the interpretation of a y-intercept is it's that value when x equals 0. So when the length is 0 meters, we would predict or estimate, we would predict or estimate, so I'm just say predict, we would predict the weight to be negative 16.46 kilograms. It is perfectly acceptable and actually a really good idea to go on and say, this does not make sense in the context of this problem. This is basically extrapolation. It's going outside of our range of values. But you're still going to interpret it. You're still going to say statistically, if x is 0, then y is negative 16.46. But then go on to say, when a wolf is born at when they're 0 meters. First of all, you wouldn't have a wolf if it's 0 meters, but that it would have a negative weight, which again doesn't make any sense. But it's still a value that exists, so you may be asked to interpret it. Okay. Part D, one wolf in the pack with a length of 1.4 meters had a residual of negative 9.67 kilograms. What was the weight of the wolf? So remember that residual is equal to actual minus predicted. Okay, so they've given us the residual to be negative 9.67. They haven't given us actual and they haven't given us predicted, but they gave us enough information to where we can find predicted. So what we're really solving for is what was the weight of the wolf? We really want to know what the actual weight was. So in my opinion, it might make more sense on this to rewrite this as actual is equal to the residual plus the predicted. Okay, so we have actual is what we're solving for. Residual is negative 9.67, and we need to find the predicted. So in order to find the predicted, we're going to take the equation that they gave us up here for the line, and we're going to plug in 1.4 for the x. So we're going to do negative 16.46 plus 35.02 times the 1.4. Sorry if I said 14, I meant 1.4. So we're going to go to the calculator and do negative 16.46 plus 35.02. We want to multiply by the 1.4 as our x. This is our predicted value. It was actually predicted to be 32.568. So we're going to add 32.568. And again, that came from this here. When we solved this equation, we got 32.568. Okay, a lot of people stopped right there, but you have to go ahead and add that with the residuals. So we're going to take negative 9.67. We're going to add the predicted, the 32.568, and it gives the answer I was looking for, which was 22.898. Okay. So this alone was worth 4 points. I didn't do any partial credit for anybody on this one. You just got it or you didn't, because you had to know how to set it up and solve for the different pieces. Okay, moving on, we're on number 12. Grass buffer strips are grassy areas that are planted between bodies of water and agricultural fields. These strips are designed to filter out sediment, organic material, nutrients, and chemicals carried in runoff water. The figure below shows a cross-sectional view of a grass buffer strip that has been planted along the side of a stream. A study in Nebraska investigated the use of buffer strips of several widths between 5 feet and 15 feet. The study results indicated a linear relationship between the width of the grass strip x in feet and the amount of nitrogen removed from the runoff water y in parts per 100. The following model was estimated. Interpret the slope of the regression line in the context of this equation, of this question. So again, we need to take our slope, which is in front of x, and put it over 1. So we want to go 3.6 is over 1, and remember that it's y over x, and it says that x is the width of the grass strip. So this is the grass strip, and this time we're in feet, just to kind of remember. And then what was kind of a weird one in this situation, it's the nitrogen removed. It's how much nitrogen is removed. We didn't really have a specific unit for that, okay? It says it's in parts per 100, but it wasn't like feet or inches or anything like that, or kilograms or something. So we're just gonna say nitrogen removed. So our slope will say for each representing 1, okay? So for each added grass strip, we predict an increase of 3.6 nitrogen to be removed, or nitrogen removed would be okay. So the 1 has to be attached to the grass strip, and the 3.6 has to be attached to how much nitrogen is being removed. Part B, interpret, and back up, I'm sorry. So interpret was 2 points again, and slope was 2 points again. So if you just gave the correct value of 3.6, then you could have gotten half credit on that one, because it was a 4, everything on the test was 4 points apiece. Okay, part B, interpret the y-intercept of the regression line in the context of this question. So our y-intercept is 33.8. It's the number by itself. It's the constant. And we want to know that that's the y-intercept when x is 0. So when we have no grass strip, or you could say when we have a grass strip of length, of 0 feet. So when we have no grass strip, or you say of 0 feet, we predict 33.8 nitrogen to be removed. So again, you take the constant and you have that as your y value, and then, or your variable that goes with your y variable, and then you want to attach it to that, and then you want to take the x and let it be 0 to get your sentence. Okay, part C, would you be willing to use this model to predict the amount of nitrogen removed from grass buffer strips with widths between 0 feet and 30 feet? Explain why or why not. There was a huge keyword, and the answer to this is no, you would not. And this is a 4-point question. You had to give no, and you had to give an explanation of why. There was a key word that they really wanted to see, guys, and I'll be honest, I didn't count all for this, but again, it's one of those things that if you don't use the keyword, you're not going to get full credit. So the AP grader, if they did not see the word extrapolation within your explanation, if they didn't see it within your write-up, they're going to take off. They're going to dock you like a half a point or a full point. So be careful of that. You can't get full credit if you don't use the correct keywords. So what we would want to say is this is extrapolation beyond the range of data from the experiment. So they only studied from 5 to 15 feet. You can't say that that's, their findings are going to be true all the way from 0 to 30 feet just because it was true from 5 to 15. So barrier strips that were narrower than the 5-foot or greater than the 15-foot were not even studied. So we can't extrapolate. We can't go outside our data and say that something's going to be true about it. So try to use that word, the keyword extrapolation, and say that you can't go beyond the data that was studied. Okay, number 13. Each of 25 adult women was asked to provide her own height, y in inches, and the height x in inches of her father. The scatter plot below displays the results. Only 22 of the 25 pairs are distinguishable because some of the XY pairs were the same. And so that knocks us down to only being able to see 22 dots. And so I'll tell you the truth, this test, this question, when it really showed up on the AP exam, they went on to actually give you the equation to use. And so it doesn't, if you Google this question and you find it, the equation is not going to match the equation I was looking for, because they created it from the 3 points that we, adding the 3 points that we can't even see on our scatter plot. So what I wanted you to do for part B is use the 22 points that we actually could find and find the line of best fit, the least square regression line for that data. But before we do that, for part A, I needed a sketch, and they did ask you to do this on the real test. Draw the least square regression line on the scatter plot above. And I just wanted a rough sketch, guys, and I just wanted you to go through the middle of the points. And I'm just going to roughly draw one on here, okay? So something like that. Halfway through the middle of the points, you have your line. The only way anybody missed this part of this question was if they literally didn't draw the line at all. Had someone come and draw the line down here, draw the line there, or just drawn it out here, I would have taken off, but nobody did that. Everybody who did, attempt to draw the line did manage to go through the middle of the points in some way. So I wasn't like getting out the ruler and measuring or anything like that. It was just a rough sketch. Did you do that? And that was worth 4 points, okay? So then I'm not going to waste your time by showing you how to put every single data point in. I really hope you know how to do that by now. But I'll tell you the points that I used on my calculator. I've already put them in to save us some time on the video, but it is a lot. So let me kind of write them off to the side here for you. Let's see. I'm trying to think of the quickest. Oh, that's a beautiful straight line there, isn't it? Trying to think of the quickest way to do this. If I should just list all the X's and then next to it list all the Y's. I'm actually going to use a little bit of our graph over here to do it, I think, just to kind of organize it for me a little bit. Okay, so we're going to put the X's here. And so I have 62, 63, 65, 65, 66, 66, 167, 368. Hope I've left myself enough room. Okay, 69 and then 370s. We have 71, 72, and then there are 2 73s. Let me run out of room here. 74, 75, 76, and 77. So those are all the X values, and then you want to find the corresponding Y value in order. So you're going to put the X values in list 1, and you're going to put the Y values in list 2. So the Y values that corresponded to each of those points, like if we look at this point right here, this is X is, that's actually X is 62, right? So it corresponds to 60. So 62 goes with 60. So you've got to go through each point and get the correct Y value that corresponds to that X. So I have 60, 60, 60. And again, these just come, let me get the pen did not be so thick again, sorry about that. So 60, 60, 60, and then 63, 65, 66. So yes, you had to really take your time and look at each individual point to get the correct data points. 61, 63, 64. And we have 69, 68, 63. 64, 66, 66. Then I have 64, 64, 65. Okay, we have 70, 65. And then 69, 66. So that's all 22 points that we can see. And again, I took those points. First thing I did when I started, I'm not going to redo it now, is I did second plus 7, and then obviously 1, 2 to clear out my RAM. I don't want to do that this time. Once I cleared out my RAM, I went to mode, and I came down to where it says stat diagnostics. Let's see if I can get down there for you. And I made sure that I put it back on. So I've already fixed that for us. Once I have my stat diagnostics on, and you might be saying like, why are we doing that again? I forgot. Because if you don't have your stat diagnostics turned on, it's not going to give you your R value, which we are going to need in part C. Okay, so what we're about to do in the calculator, it's going to give us our answer for part B, but it's also going to give us part of our answer for part C. Okay, so I'm going to go stat, edit. I'm going to put all my X's in list 1. I'm going to put all my Y's in list 2, which you can see I've already done that. So then we're going to go to stat, over to calc, number 4. and we want to come down to calculate. A lot of people during the test came and said, Ms. Hall, how do I get the y there again? So if you want to remember how to get the y, all this is going to do is take the equation and store it into y1 for you. So if you want to get the y there, you go alpha trace, and then y1 pops up, you select it, and you go down to calculate. You don't have to do the storing, okay, but you can if you want to. And so now I have a lot of information that I need. So on part B, based on the 22 pair of student scatter plot, use your calculator to find the least square regression line. So our line is going to be y hat equals our slope on the calculator's that a value, but let me write it without the values plugged in first. So this is from the formula sheet. If you forget, it's supposed to be y hat equals b naught plus b1x. On the calculator, b naught is actually a, and B1 is actually, I'm sorry, I said that backwards, guys. Let me erase that and take it back. The slope, let me just start again. Whew. Y hat equals B naught plus B1x. That is from our formula sheet. Now, B naught is our y-intercept. And on our calculator, the y-intercept is B, okay? B1 is our slope, and on our calculator, the slope is A. Okay, so we want the answer I was looking for is y hat equals 34.62 plus 0.43 x. Okay, this would have gotten you a perfect 4 points. But I tried to be reasonable, I tried to be nice, and if you had the correct form of the equation, I gave you credit. And so some of you might see that I marked off for your y-intercept and I marked off for your slope, okay? And that's because you had it in the correct format, you just had the incorrect values. So I was trying to be really fair and give you some credit just for knowing what the equation of the line was supposed to look like, okay? And then for the r value, I was looking for 0.6214. If you did 0.62, I gave you credit. And that was only worth 1 point, as the whole question is worth 4 points. So the correlation was worth 1, the direction was 1, the form was 1, and the strength was 1. So even if you messed up putting your data into the calculator, you still got a lot of credit for just doing the equation in the right form and then being able to tell me the direction, form, and strength. And honestly, you can look at the scatter plot and see that without having to run anything. So again, like if you didn't put the data in correctly, it was a minimal deduction of points. It was like 3 points total that really hurt you. And I'll tell you in a second, when we get down to using the equation for part D, if you got the equation wrong in part B, I recalculated for you to try to give you as much points as possible to even giving you credit for part D. So I accepted different answers on part D depending on your original equation from part B. So I really tried to be fair in grading this. But the direction of our scatter plot is positive. The form of our scatter plot is linear, and then the strength of our scatter plot was really moderately strong. I saw some people using mediumly strong. I saw some pretty strong. Try to use the correct terminology. Honestly, I don't know if I haven't seen in the scoring guidelines where they'll take off of the word, medium strong or pretty strong. I haven't seen anywhere it says they have to use the word moderate, but let's get in the habit of using the correct terminology. And so if we have a somewhat strong, not super strong correlation, then we should call it moderately strong. We want to go with strong, moderately strong, or weak. And this one is moderately strong, okay? Part D, one father's height was x equals 67 inches and his daughter's height was y equals 61 inches. Circle the point on the scatter plot above that represents this pair. So I'm going to start there. I'm going to go back. We have to circle the point that is 67, 61. So excuse me, you'll notice that the x-axis goes by 2s. So 67 is going to be right here. 61 is going to be right here because the y-axis also goes by 2s. And so that corresponds to this point right here, okay? So that was worth 1 point. I don't think anybody got that wrong, but here's the part that people did get wrong. So circle the point, that was worth 1 point. Then you also had to draw the segment that represents the residual. Remember, the residual is the vertical distance from the actual value to the predicted value. So it should have been the actual value to the predicted value. You should have drawn a little bitty vertical line right there. and that was worth a separate 1 point because it's from the scatter plot to the prediction. But I saw people drawing little diagonals. You know, this is not Pythagorean theorem. We're not measuring hypotenuse or anything like that. It was a vertical distance. Straight up and down distance was what I was looking for. So that was worth 1 point. And then we actually had to find the value, and the value was worth 2 points, okay? So the value of the residual was 2 points. So what you needed to remember was that the residual is equal to actual minus predicted. That's where I told you to try to remember RAP. Okay, so the residual is what we're looking for this time. The actual was given to us, and you want to go off of the Y values, okay? So the actual Y value was 61, minus we're going to have to find the predicted Y value when X is 67. And so that's why I'm saying I went back, and if you did a different equation than what I did, I went ahead and recalculated it to try to give you credit. And so remember that our equation is Y hat equals, let's see, 34.62 plus 0.43x, but instead of x, we're going to plug in 67. So this is going to allow us to find the predicted height of a, let's see, it's the predicted height of a daughter based on a father who is 67 inches tall. So back to the home screen, I'm just going to go 34.62 plus 0.43 times 67. And so she is predicted to be 63.43. Okay, this came out to 63.43. Some of you, since we stored it in Y1, maybe you figured out that you could just go to the table of values and get the prediction off of that. And so again, we stored it in Y equals already. I'm kind of lazy. Y'all know that about me on the calculator anyway. I want to do shortcuts. So I'm going to go to my table and I'm going to plug in that I want to go to 67, because I don't know about you. What I meant by I'm lazy is I don't want to go from 0 and arrow down 67 times to go see the data point I'm looking at. So that's what I mean. I want to do things efficiently. So change my table start up to 67, and then I go second graph, which gets me to the table of values. And so you'll see that it's predicted to be 63.532. So it's a little bit off from what we're seeing by plugging it into the equation, because we've rounded the equation. Honestly, what's on my calculator screen right now would be more accurate. Okay, so I did take, you know, some different decimal places and stuff like that into account when I was grading part D. So let me go ahead and finish this problem out. So we're going to go with the 63.43 as our predicted. And so we want to do 61 minus 63.43, back to the home screen. Okay, so 61 minus 63.43. And again, you didn't have to do all that table stuff. I just wanted to show you for those of you who are using the table. So that the residual is negative 2.43. So that's what I was looking for, and it was worth 2 points. To get that correct value or something super, super close to it. And you should have shown your work. And again, if you had a different equation, I did replug in to see if I got your answer and tried to give you credit for that. Okay, part E. Suppose the point x equals 84 and y equals 71 is added to the data set. So let's go back to the data set and add the point 8471. Okay, 8471. So 84 is going to be here, 71 is going to be here. So that's adding that point. Looking at my picture right now, if a student drew this on their, on their paper, I gave credit for you saying that the slope was going to decrease, that the slope was going to be less steep, that the slope was going to get closer to 0. But guess what? It's wrong. It's not true. But based on your picture, I tried to give you credit. Let me show you why it's actually not true. Okay. So if we go into our list, and I haven't done this yet, saving it to show you. So we can go into our list, and it is quite a bit of clicking, but we want to go to the bottom of our list, and we want to add the point 8471. And let's see what actually happens when we rerun it. So there's 84, and then I want to arrow over and type the 71 corresponding with it. So we've added the point. Go to stat, go to calc, number 4, rerun it with our new values. It doesn't matter if you store it in Y1 or not. So we calculate it, and now our slope is 0.4348. Our correlation, let's see, I'll call this B1 to be correct. Our correlation is 0.7067. So if you look at our original slope, what was our original slope? Our original slope was 0.43. And actually, if I go back, let me see. Let me actually just tell you, okay? Originally, if you keep more of your decimal places, I didn't up here, our slope was really 0.4315. You can even rewind the video and check what came out on the calculator earlier, but it was 0.4315. So I hope you agree with me that from 0.4315 to 0.4348, it actually increases. It actually increases, even though I did accept decrease if your picture showed decreasing. I even accepted remains about the same. If your picture, when you drew it, if it looked like your line was in line with that point, okay? So then we get to the R value. I did not accept decrease for the R value, guys, because that point is not an outlier. And I did have people saying it was an outlier, but it's actually, if you look at it, that point is in line with this scatter plot. It goes with this scatter plot. In fact, it's going to strengthen your R value because it's just one more point that fits that data. It's not out, if you had the point out of line, like way up here or way down here, not even there. That's not really a good example either. But if it wasn't in line, like let's say it's out here, if it's not in line and it's going to pull the data, then yeah, it's going to weaken your R value, your correlation. But the dot that they gave us was in line with the rest of the points. Okay, hopefully you understand what I'm saying. And so what I was really looking for you to say, and you can verify it by what you got on the calculator, was that your R was actually going to increase. So again, it went from 0.6214 to 0.7067. It got stronger. I did also accept remains about the same. I did not accept decreases. It's just not true, okay? There wasn't validity for that. Not even from your picture. I couldn't give you credit for that. So again, these were 4 points apiece. And with your multiple choice and everything added in there, everything ended up being 4 points apiece. So I hope that helps you understand your free response a little bit better. Thank you.